Well, that's interesting, isn't it? I am not hearing what I need to be hearing, so we should just post-produce this.
Okay.
Well, I've lost, because you've gone away. Audio was coming through you, so I've lost audio off the Hangout, I guess, is what it amounts to.
Okay, well, in that case, but your doorbell's ringing.
That was mine. Sorry.
That's not me.
All right, folks, this is
Yeah, right.
VUC 496. Hey, we're coming up to 500. And we're going to be talking to Emil and the team about the Jitsi Video Bridge status report. Sounds like a big deal, but actually we're going to break this thing or make this thing, or both. This is fantastic, and we're also testing the recording of same. So we're going to do a shout out to the sponsors, first of all, because they help us make this thing happen. First of all, the Simwood.com, who can turn developers into telcos. If that is your wish, go to simwood.com. Simon Wood, by the way, is a really interesting guy. You should check him out. He's on Twitter. And it's unfortunate that I don't know his Twitter handle, but you can search and find it. Simwood.com. Also, for a long time now, we have been, first of all, I've been a customer of onsip.com, hosted PBX for a long time. I don't care to host my own PBX, especially in the U.S., and they help us out with the VUC hosted PBX. Of course, zipdx.com. Hopefully you're listening to that and hearing us on zipdx.com. And voxbone.com, who supplies the local rate dial-ins in 48 world cities. And if that wasn't enough, we have Jitsi. Andy is telling me that live.vuc.me is good, which means you can go there and watch this circus, live wire with no net, if you want to see the video. It is delayed by about a minute, so it would be really strange if you're listening on mixler.com/VoIP users if you want to use a portable device. Anyway, let's talk to Emil. Emil, give us a little background. You guys have been on about 80 times now because we really like what you do at Jitsi. But for those who haven't maybe seen the preceding in this series, a quick background on how Jitsi started, because Jitsi started as, and now you're going to even have to tell me right away what it used to be called, SIP Communicator.
Exactly, yes.
See how it comes back? The kid's not dead yet up there. Anyway, let's go from the parcours from 0 to 60 in about 10 seconds, and then we'll talk about Jitsi and Jitsi Meet, because it's very confusing to know that there's a Jitsi client, and then now there's Jitsi Meet, which is web to RTC. Give us a quick, full picture.
Absolutely. So Jitsi started as a rich client. You said it yourself. It was called SIP Communicator. That basically means that you install it in your computer and use it to make SIP calls or XMPP calls. Then it started evolving. It was capable of doing of mixing conferences, which basically meant that I could call you and James and Lubomir and then mix everyone into a single call and everyone would be talking to each other. So with those features, and we actually added video to that as well, so it was possible to relay video from all the participants. Jitsi was becoming actually a very rich piece of code, and we thought one day, oh, it would make a lot of sense to run that on a server, because you don't want to run your conferences on your computer. It's too unreliable for that. So we took the core of Jitsi, we made it work on a server, and that's how Jitsi Video Bridge was born. So think about Jitsi Video Bridge as just a Jitsi running on a server capable of relaying and mixing stuff. So about last year, toward the end of last year, we added to Jitsi Video Bridge the possibility to connect to browsers. That meant adding support for DTLS SRDP, adding support for ICE on the video bridge, and a few other things. And from then on, it was possible to use that code, which had been born as a client and was now living on the server, to just connect multiple Chrome instances to it and basically reproduce things like Hangouts. And Lubomir has actually, Lubomir, who's actually in Apple, has been responsible for a lot of the code in there. So he's really the superhero of Jitsi Video Bridge and all of these new features. Yeah, that's the thing that we're currently using actually is a WebRTC application, a JavaScript application called Jitsi Meet, which connects to the video bridge and uses its capability to do multi-party conferences. The first version of that, I would just like to give a hat tip to Philipp Hanke from NGET, who wrote the first version of that he then contributed to the community, and everyone's been contributing to that ever since. So we did present Jitsi Meet and Jitsi Video Bridge here. I think it was just over 2 months ago, and we are now back because we have a number of interesting developments there, and we think we're getting really, really close to something that can be reliably used for the VUC, not only to replace Hangouts, but also make your lives easier and maybe help you avoid a number of the gatewaying and bridging that you guys have been obliged to do in the past session. So that was a little bit over 10 seconds, I know, but I just wanted to give a good reminder of everything.
Okay, thank you. We're done. But all kidding aside, one of the things I keep reminding you of is an important issue today, which is that first of all, in case it isn't clear to those who aren't really so much in the open source world, suppose you've got an enterprise, whether it's small, medium, large, whatever, and you have certain needs for conferencing, you can, assuming you have someone who knows how to do this, and I don't think it's rocket science, I think it's people who are competent in doing things like installing servers and working in the cloud or local services, either one, all of the code can be downloaded and it can be installed. And obviously if there are problems to be solved, you can contact the Jitsi team for that. Obviously also extensions, new development, I mean, that is what they do from day to day. But what I was going to say that's really important and that never gets said much is that I happen to be in France. Emile is often in France. He's not there now, I guess. But the point is that if you have a French company, you can keep all of the network stuff in France by using your instance, which is in a country. And this whole borders, data crossing borders thing is, first of all, it's a huge issue in Europe, as you know, Emile. And also maybe in other places. I'm not trying to react to the revelations of Snowden and the NSA. That's not my point. My point is that if for any reason you wish to avoid going through, say, Google, or not having any control over where all the data is going, then this is a solution to that. And it's a solution that does not require any particular thing except that you've installed it.
Right.
So that's really important.
I actually like the fact that you insist on this not just being the result of the Snowden revelations, being able to install your own thing. I think most of the VUC regulars know very well the difference between using Skype and using your own asterisk installation. And we're talking about the same thing here. You can deploy your own bridge, configure it the way you want it to. If you record stuff, it will be on your own servers. The security would be exactly as you expect it to be. I mean, you won't have to, how should I say that? Let's say that when you're talking to a service, to an existing service, you don't really know what happens, what level the security is at. Whereas when you're installing your own stuff and you know the product that you're installing and its security capabilities, you know what to expect and you know whether that works for you or not. So I agree that this is really very important. And in terms of deployment, actually, we're currently working on making the entire thing, and there are a lot of components here, because in addition to Jitsi Video Bridge, there's Prosody, the XMPP server, there's Nginx, the web server, and we're making sure that all of these things are deployable as Debian packages, so that you can just add a Debian repository to a server and handle the entire thing with an apt-get install. And there you go. You have your own Hangout server that you can use on your own premises.
Exactly, and that means that you're not depending on. And there's nothing wrong with Google Hangouts, by the way. I've used them since they've existed. They're great, but you are still going to be dependent on that particular phenomenon. And let's face it, anyone who's listening to me now, you guys, most of our audience is very hip and has followed the history of VoIP and of telco and so on. So you know that if I say the word Google Voice or what was the something, the rug just got pulled out on May 15th for the XMPP connection. Long story short, you are dependent on what Google wants to do and feels like doing. You know, right now we're transmitting this on a YouTube Live channel, but Google tomorrow could go, well, this YouTube Live thing's great. Let's charge some money for it, or let's not do it anymore, or there's a reason. Whatever they want to do is what they want to do. This code, yeah, admittedly, if the Jitsi team didn't feel like supporting it anymore, then that would be a dead end, I guess. But you've still got everything and can continue with it. Well, I mean, as opposed to being dependent on an infrastructure. In other words, if you do this, if you download this and install it on your own infrastructure, you still have it all working. It's up to you after, if for any reason the team could discontinue. That's what I meant, Emil, is that if the team for some reason and that does happen, a project stops being developed. But the whole point of open source is you've got all the source there, and if you are happy with what it's doing, you can not only continue to do it, but you can also extend it. You know, unless somebody breaks JavaScript and whatever else, you know, in HTTP and whatever else is being used, it's perpetual.
It is, and there's a difference between something dies because there's no theoretical possibility for it to continue, or something just loses its main contributor, and then there's really up to, is this valuable enough for the community to keep supporting it? If, let's say that we all went on a team building vacation tomorrow and an asteroid fell on our bus and killed us all, then everything we've done is open source, and if our code is useful, people would continue modifying it. And there are already a bunch of people that actually are using GT Video Bridge and GT Meet. That's actually quite interesting because we're seeing an adoption for GT Video Bridge, which is much, much faster than the adoption that we've seen for Jitsi. So there are people, I know that, for example, there's this French company that does a lot of work in WebRTC called Happy Days. I know that they're using libjitsi for similar purposes. Comcast have been funding some of our recording work, actually all of our recording work. So we hopefully they would be using that as well. And all of the people actually using Video Bridge are very close to developers and very likely to be able to continue working on it, even if we all die tomorrow, which of course I'm hoping won't happen. Yes, everything, all of this is open source, and I think that changes a lot in terms of reliability.
You know, what I was referring to, for example, a lot of people have heard the story of TrueCrypt. I think that's the name of it, TrueCrypt. So the guys who were the people who were developing TrueCrypt just suddenly put on the website, TrueCrypt is over. You know, if you want to use it, here's the source. Or they just stopped. Right. And they said, in fact, that there was a cryptic message saying that it's no longer secure. I don't want to get off on that digression, except simply to say that anything is possible. And I'm certainly not saying that anything would happen to any of you, but simply that if for any reason development didn't continue, it's different from some huge entity like Google saying, okay, this is how it's going to be now, because you've got all the code. So that's what open source means, and I don't think I have to beat that horse too hard. Let's open it up and see if anybody in the Jitsi Meet. Hello. I just got back from Tokyo, and boy, am my arms tired. I just flew in. Bob, what were you going to say?
Yeah, thank you, Randy. Yeah, I could tell. Got a few feathers on me.
Oh yeah.
Emil, I had a couple questions actually. Right now, I assume this is all posted on the Jitsi servers. And so whatever bandwidth is being consumed is the cost and burden is on Jitsi. Is that correct?
Well, yeah, the burden is on the server that hosts the Jitsi Video Bridge.
Does this, so the question is, I guess when you're doing it, obviously a Google Hangout, it's being hosted by Google and there's no cost, I guess, essentially for that, versus if you put this out on your own server, then of course any additional bandwidth costs you would be incurring.
Right, that is true. But if you take a look at, say, digitalocean.com, I think if you're a small company and you're thinking of having conferences with 3-4 people maximum, the $5 a month machine that they have would probably be enough and give you all the bandwidth you need and all the server. If you have a slightly bigger team, then $10 a month would probably be enough. So we're not talking a huge bandwidth here. This is totally manageable within even the most common virtual machine offers that you have out there. So we're not particularly worried about that.
Mm-hmm. I mean, do you think at some point, as the video quality improves, of course, the bandwidth expands and now becomes more of an issue in terms of supporting the cost of it?
Hi, that's an interesting question. So basically, you're saying, what happens if everyone starts transmitting 4K?
Yeah, exactly.
Right. I don't know. It all depends on how pricing varies and I mean how bandwidth pricing varies and how quickly 4K becomes something widely used. But there's something else though. A lot of the work that we're planning on doing in the following year would be exactly about optimizing the bandwidth usage on the server. Things like simulcasting, for example, can be, and I think Bernard would be here. Bernard Aboba from Microsoft will be on the BUC next week. So he's a very, very knowledgeable person on all these matters, and I'm looking forward to hear him talk about this. But things like simulcasting and scalable video coding can hugely improve the bandwidth consumption on solutions like the Jitsi Video Bridge, where basically what they change is that there's no longer everyone streaming a high quality video to the server and then that's being redistributed to everyone. Once you have a selective forwarding unit like Jitsi Video Bridge that's capable of understanding simulcasting, then it could just, let's say there's 10 of us here, and all of us are capable of streaming out 4K, but we're also streaming a lower quality stream so that if we're just appearing as thumbnails on everyone else's station, then only the thumbnail stream can be redirected by the video bridge, and that can substantially reduce the bandwidth that it's using. It can even tell you, hey, Bob, there's no point in you streaming the 4K stream because no one is watching you on their main video currently. So you can just send me your thumbnail. And as soon as someone clicks on your image, the server is going to tell you, now you can start sending me your 4K video because Randy wants to see, or because you started speaking. And right, so these are the things that we are working on. We actually have started this collaboration with UNICEF. They're very interested in things like optimizing bandwidth, for example. So obviously, because in Africa, for example, there's not always hugely available bandwidth, although that's actually improving pretty fast. But they want to make sure that when participants join from places where you only have 128K, you can still join a conference where everyone else has 20 megabit at home or 200 megabit or etc. So,
as it happens on the Hangout, Emil and Bob, Michael had inserted his, and you guys can't see this, but the people who are looking at the Hangout and eventually the recording will show this. So he's got a graph up live of what he's putting out right now, and he's on both the Hangout and Jitsi, and it's
Yeah,
just
so
over to
I'm
go.
showing
Go ahead,
the
Michael.
data across. I'm showing the data across my router for being both. I have two instances of me being on Jitsi and one instance of being in the Hangout, and so that's what my monowall router is seeing in real time just now.
Which looks like about 2.3, 2.4 megs.
Yeah, that's the inbound, and the outbound is about half of that.
Yeah.
Okay. Well, here's the thing for you. I'm currently on a very poor internet connection. You can probably tell that from my video. It must be relatively low quality.
Mm-hmm.
I'm currently streaming at 20 kilobytes per second.
Wow.
And am receiving 100 kilobytes per second, so less than a megabit. This is just with the inbuilt adaptivity that you have with WebRTC, and we're already coping in a situation where we have different capabilities. So once we go on and improve on that, it will be, I don't think bandwidth would be a concern for anyone.
Yeah, Emil, it's James. Can you just give me those figures again, because I kind of blinked and missed it.
Right. So I have 100 kilobytes receiving, about 800 kilobits, and I'm sending 20 kilobytes per second.
That's incredible.
Yeah, because I'm on a very poor internet connection right now, and I apologize for that, by the way.
Emil, just when I switch my views here on the bottom, is it switching it just for me, or is it switching for everybody?
Okay, it's great that you're asking this question, because that was one of the things that we wanted to talk about today. That's why Lubomir is smiling, because he knows that his turn is coming. When you are switching the speakers manually, it's changing them for you only. If you now click on me, for example, you'll see me because that's your choice. Everyone else would continue seeing the active speaker. If you click the second time on me, then it would switch you back to what it considers to be the currently active speaker, even if that's me again. And actually determining who the currently active speaker is something that we've just added recently. And it's actually a very interesting thing because on the bridge, for example, we wanted to avoid to have to decode audio. I'm going to turn over to Lubomir in just a second. I just wanted to remind that the way that this bridge is working is it's an architecture that's usually referred to as an SFU, a selected forwarding unit. It's not a traditional MCU where all the streams arrive, they're decoded, they're mixed, they're re-encoded with potentially some quality loss in the process because you're basically re-encoding and losing information once again, and additional latency. No, what happens is that every packet is just being relayed to all the participants. And that actually makes it a little bit tricky to do things like detecting the active speaker, because unless you decode audio, you don't know what's in it. Well, it just so happens that with WebRTC, every RTP packet does carry information that will allow you to determine who the active speaker is. So we get all this information in the video bridge. That information travels in RTP extensions for the ITF aficionados. I'm going to just give a number here. It's RFC 6464. It defines how that information can be transported, and it becomes very, very usable to the bridge. So Libo, do you want to tell us a few words about how we make dominant speaker calculations and how we decide who is the current dominant speaker? And then maybe you can comment on what you're seeing here and what ideas you have for improving it further as performance for that algorithm, because it's a very new implementation. I'm going to stop asking my question now because I've been asking it for more than a minute. It became a very, very long question. Yep, up to you.
So yeah, we started from a very interesting and advanced algorithm, but then we had to satisfy the restriction to not decode the audio. So it turned out that we had to make do with audio levels sent from.
I'm sorry to interrupt. Can you just remind the name of the paper that we were using?
I was on plan. So we started from the algorithm dominant speaker identification for multi-point video conferencing. It's written by Ivana Wolfin, and she's co-authoring it with Israel Cohen. Yeah, we had to modify it in order to make it fit into our requirement. So first, one disadvantage that we have is that we have to rely on audio-related information coming from the remote site, and we cannot analyze what we've received, which means that each endpoint may have a slightly different measure of that audio, how it relates to the other audios. What the algorithm does is it's looking at the speech activity in intervals of varying length. So they could be, these intervals could be compared to a few phonemes, a few words, and maybe a sentence. The algorithm is not so much detecting who's speaking, it's trying to detect when there is a change in the dominant speaker. So there is a person who is currently dominant, he's the active speaker and he's talking, he's dominating the conference, and at every interval, the other participants are trying to take the dominance from him, and either they succeed or they don't. The score is their speech activity in the recent intervals. So that's pretty much the theory behind the implementation. What we're seeing now is the results of that with some minor issues, since this is like a beta. And we're seeing here, maybe we're seeing here those effects, those negative effects that I mentioned, that we're getting audio levels from the peers, and they could be based on different scales. Then again, we have to add, I think, we have to add to take into account the notion that the human perceives the strength of an audio signal differently depending on its strength, which we're currently not doing, and we hope to, with that, to bring the differences in the endpoints, how they perceive the audio level, and bring them to the same base on the video bridge. So this is pretty much what I have to say without further questions. I mean, if anyone has questions, I could try to.
I guess I maybe just, if someone didn't follow, I just wanted to summarize it, that basically what Lubomir described as our main problem is that currently every single participant just tells the bridge, hey, I'm speaking loudly, or hey, I'm not currently speaking, or hey, I'm just making a little bit of noise. And then the bridge has to say, oh, if you're speaking loudly, then you're the active speaker. And obviously, if there's some sort of a miscalculation, whether it's voluntary or involuntary, it doesn't really matter, then that completely um, messes up the calculations on the bridge, and you might end up seeing on the screen not the person that you're really expecting to. Now, luckily, currently we're in a very limited scenario where all the participants have the same implementation because we're all using Chrome. But even now, if some of you guys is on Linux, for example, we wouldn't be getting any audio levels from you because apparently there's a problem with the audio levels on Linux, audio level support on Chrome. So it's still problematic, and we need to improve on.
Have you thought about excuse me? Have you thought about using visual for determining who the active speaker is? For example, looking at with image recognition today, you can find out who is looking straight ahead, whose lips are moving, whose hands are moving. A lot of people speak with their hands, and be able to use some of those too.
Yeah, if we do that, then James would be active speaker all the time. So, but the thing is that we do not currently look into the audio at all in order to try and save resources. If we wanted to even go and start looking into the video, then that would be very, very expensive. It's obviously something that would make a lot of sense because I mean, that could actually be a very good way to distinguish between noise and between actual speech activity. But that would mean that the bridge would have to decode and analyze every single frame that it receives. And that would be very, very heavy. So, but maybe someday we could come up with an algorithm where this analysis is also made by the participants before they encode their video. And they just stick it as some sort of an audio level into the RTP packet and send it to the bridge so that it can just use that meta information. That way it could probably work. Yeah.
What you want to do is be have it like a computerized director, and use AI to replace what a normal TV director would do. And
right. Well, actually, Michael explained to me the other day that the way things happen in the film industry is that they have some on-site director that produces how was it called, Michael, the line cut or.
Sure. Well, and relating to what you do, Bob, what I was describing to him was the value of, in the process of recording, was not so much speaker detection, but was the process of recording the individual video streams as opposed to, in parallel with using active speaker detection to do what we would call the equivalent of a line cut. Having, in the process of recording, which we're going to get into, if you have the individual isolated camera reels, then as a post-production editor, I could go back in and say, you know, I really didn't like the switch to that camera shot was late, so I want to go back to the original footage and cut in the shot ahead of when the speaker actually changed, as a post-production process. So I definitely do appreciate the fact that having the access to the original streams for all of you in these little windows down here in front of me gives me tremendous flexibility, particularly if this is a live event, but I'm going to make the webcast of this available as something after the fact forever. I can go back and tweak that and make it perfect. Anyhow, and that leads into this idea of recording, which
right.
Hey.
Yeah, but so just whatever Bob, when Bob you said what we need is actually an artificial director. Is that's what we're trying to do, and have the line cut as you guys call it in your industry. So even if it's not perfect, it's not that much of a problem. And even if showing someone's expression on the face at some point was more important than showing the active speaker, which is often the case with James. Yes, I was sure you were going to do that. And so that can happen after that in post-production. So
yes, if I might jump in for just a second to circle back on Bob's earlier point, anything that you do in picture is really, really technically very high cost. It's also error prone. For example, you see the lovely terrace doors beside me? My wife comes in and decides that she's going to open the door, it's going to change the scene from a lighting point of view quite dramatically, which is not necessarily indicating that I'm meaning to speak. In fact, in that case, it's probably meaning I need to be muted. So
I think we need to.
Not always the parallel is between what's going on in picture and what's going on in audio.
I think there's. I totally agree with you, Michael. And I think there's another point that needs to be made here, which is that of what exactly you're trying to do with the tools available. And one of the things, and we've all agreed on, is that video is very poor in showing slideshows, for example. So if you're going to do a presentation, it's not going to work well, and we've proved this many times on our own VUC. It's not going to work well with video. Why? Because the video is expecting stuff that's moving. So the various optimization algorithms for video are screwing around with constantly looking for changes and so on. What you really want is either a data channel or a web channel. In the case of what we would be looking at using Jitsi, and we've done this, Jitsi Meet, we've done this before. Last time we did a demo where we showed the Prezi presentations. And the point is that the last thing you want to do is show slides on video, because they're never going to be clear and they're never going to look good. I'm bringing this up because if you're, besides the jet lag, which is causing me to go all over the place, if you're trying to if you're trying to do this auto direction thing, here's what happens in the reality, which is that if we're talking to someone, whether you're in a corporate environment or a presentation, whatever it is, you're talking to someone, and basically most of the time you want the active speaker to be on. And often you can manually just stick that active speaker on and let them show their slides and do their demo and then show themselves. And Michael has done some things also where there's a side-by-side. You can do that with Wirecast and a couple other presenters where you're showing like slides on one side and there's kind of a perspective effect. And then or you've got what a friend of mine used to call the Tidy Bowl man. For those of you not in America, this is the little guy that they put into the toilet bowl, and he was superimposed in there. And basically what that means is, in fact, that's kind of what I'm doing now, except that instead of a toilet bowl over here, I have some notes and some text. But the
you
point,
look awfully flushed.
well, I've been in the sun. But the point is, you really, really, really have to pay attention to what the needs are. And I think that you'll never get anything automatic that's going to work as well as someone who's actually running the things. And I say that, because generally I do run the thing. I'm not today because we're using Jitsi. But the other reason is that it'll never be as good. It will be as good if you're just having a straight conference. If we were just talking to each other with nothing else, in other words, if there were no live presentation, which there is on YouTube right now, actually a straight auto switch would be fine. But a lot of times you've got the problem of extraneous noise coming in. We had it a few minutes ago. We had some terrible echo coming from somewhere. Or people who are joining. So it's way more complex than auto switching, in that if someone comes in and they're not muted or there's a noise, it's very, very common for, during the Hangouts, for example, for people to be coming in and out, and all of a sudden, let's see, how can I do this? I can't really do it because we're in Jitsi now. But if I was on Hangouts, you can just randomly switch to someone else. And that's the effect that you get a lot of times when people come in and they're not unmuted. So, long story short, auto isn't enough, but it's nice to have as a basis. I think that's pretty clear.
I concur with you totally there. I like to have control, being a bit control freaky, and the ability to select who I want to look at is really, really useful.
Well, that's the local. Okay, there's two different things too, and I think that got covered a little bit a few minutes ago by Emil. But you also want to be able to look at, hey, let's face it, if we're in some boring conference and somebody particularly good looking is in it, you click on that and you can watch them.
Yeah.
But
anyway, can we just rewind a bit and go back to the HTML5 apps piece? Because I think that there are lots of people out there who kind of half get the concept, but I didn't get the true power of the HTML5 embedded apps until I saw it all working within Jitsi Video Bridge. So, Emil, is it worth just spending about a minute or so just going over how the HTML5 embedding works? In fact, explain how easy it is to embed an HTML5 app into Jitsi Video Bridge, because I was blown away with how easy that is. Yes, Randy.
We love the screen behind you, James.
Sure. I completely understand what you mean, because I should probably start a little bit earlier and talk about the fact that we've had, before adding WebRTC compatibility in Jitsi Video Bridge, we've had it working for about a year, maybe a little more. Throughout that time, we've been struggling. The only thing that was able to show video from Jitsi Video Bridge at that point was Jitsi. And we've been working really hard on making Jitsi show video conferences from Jitsi Video Bridge. We had that kind of working in the beginning of 2013, because I think that's when we were last on the VUC before in last year. And since then, we were just making sure that whenever people come and go, that they would disappear properly. The user interface was very tricky. We wanted to make sure that they're being laid out properly. Our entire energy as a team was being consumed by working out the user interface in Java Swing for our video conferences. And then came our WebRTC compatibility and the possibility with that to make the interface on HTML5. The first version of Jitsi Meet was probably done within a couple of weeks, first by Philip Hanke and then by Jana, who started helping with the user interface. So from that point on, presentations online, because that's the thing that people want to do most often with video conferences. Yeah, but we don't really want to deal with things like storing presentations on our own services because we don't have authentication yet. We don't want to deal with storage, assigning storage to people. Isn't there an easy way to do that? Oh, there's this nice presentation service called Crazy out there. Why don't we just integrate it? Okay, let's do that. A day later, it's in. Then we think, hey, by the way, it would be good to do some collaborative editing. Why don't we do that? Isn't there an existing application for that? Oh yeah, there's Etherpad. Let's go and integrate that. A day later, it's in. And every time an idea pops up, it's implementable in HTML5. Really, you get a prototype within a day. Then obviously James comes over and says, well, this LivePad thing actually looks much better than Etherpad. The Jitsi folks wouldn't want it because they want to have an open source system. But why don't we do that in TruePhone? And I'm sure that if they put their hands on that in TruePhone, a day later they would have it. Because really just this is where WebRTC has made the biggest difference for us. Achieving the user experience that we need and getting the user face that we want, it has become a matter of days as opposed to months previously, or even years. I'm equally impressed by that, James. And so now today we can concentrate on working on the video bridge and on stuff like RTP and reporting. Going back to WebRTC, actually, I just wanted to add two things about the active speaker. The first thing is that that active speaker implementation has been funded by Simwood, so I forgot to say that previously. I want to thank them now. Thanks, Simon. Thanks, Simwood, for helping us with that. And the second one is that we're actually using data channels for delivering the active speaker information within these conferences. And I think this is pretty cool because many people see data channels as the big innovation from WebRTC. Maybe I'm not as excited like as Tim Panning, for example, but I really think they can be very, very useful in exactly cases like this, where where you need to deliver real-time information, like who's the active speaker now. This needs to be delivered very, very quickly, and data channels are the best way to do that. If you want to do things like controlling simulcast or last stand implementations, then again, data channels are something that allow you to send metadata information, control information together with your media packets, and they are really, really very, very convenient for that. I don't know if someone is burning with desire to interrupt me, but if no one raises a hand, then I'm going to go ahead. No, I don't see any hands.
I will say, Emil, that I'm showing on the YouTube recording my own bandwidth usage, which I won't even comment on. But if people are watching, they're welcome to watch it. Now Michael is showing it on that. And so I've switched back, and I'm going to have to go in about 15 minutes. So we've still got 15 minutes to continue the YouTube broadcast.
Yeah,
this is a kind of a weird,
Randy, I'm getting that in a very blocky quality. In fact, it's not particularly legible where I am. I'm just wondering whether that's due to my video stream adapting down, or whether it's because your uplink is sending it in kind of blocky mode.
It probably is me, but that makes me want to comment that this is yet another idea that one could imagine using this rather than trying. See, I'm trying to send video as a screen capture, and what would be interesting if I'm showing this waveform, this bandwidth usage, it would just as well be once every 5 or 10 seconds, one frame every 5, worst case, one frame a second, and showing it clearly. So this is another.
But actually, you can do that in exactly that way if you were sharing your screen through Jitsi, because I think now you're doing it. You're sharing it through your local artificial device.
Okay,
right?
But of course, I don't dare move to the sharing and the.
Yeah.
I could, only because I hadn't tried it before, so it'd probably kick me out or kill the browser.
Sure.
But
let me pose a question then for you, because in the Google events of last week, one of the things they were talking about was adaptation of sort of the ability to do. Oh, that's interesting. The ability to do more lower frame rate and do much higher quality screen sharing. What was it that Justin Uberti said? They wanted to make the screen sharing experience a first-class citizen within WebRTC.
Mm-hmm.
Did you track any of that, Emil?
I haven't seen the talks, but that's actually already the case with what they do in the Chrome implementation. Mm-hmm. Currently, if you go and share your screen from Jitsi Meet, you just click on the screen sharing button. It's going to send a very, very high quality screen image with a very low frame rate. Possibly, I think it's something like twice per second, or maybe even once per second, 1 frame per second. So you get exactly what you'd expect from a screen sharing situation. I don't know if they've planned additional work in that direction, but the bases are certainly already there.
I think that there was a plan that something in the coming couple of releases of Chrome were going to further improve the screen sharing experience, which would be welcome.
Okay, so that's interesting. Yeah, that would be great. That'd be great.
And
I think since we have only 10 minutes left now, it would be good to talk a little bit about the other big thing that we've added to Jitsi Video Bridge, and that's the possibility to record sessions. That one was funded by our friends at Comcast, and which we're very grateful for. And Boris has been spending a lot of time on that during the past several months. And Boris, would you like to give us an overview about how these things are working? You're actually currently recording this session with these new tools, so
great.
Yeah, we are currently recording the session as well. So as opposed to the recording which you guys are doing and posting live on YouTube, we do the recording per stream. So we don't record a single video. We record each video separately and each audio stream separately. And then after we have all that, we mix them together. This allows us to do lip syncing, for example, and also to, as Michael said earlier, to possibly switch the big video, the full screen video in post-production. So should I go into the technical details, or?
Yeah, I'd be interested to see what the user interface, I know it's in early days at the moment, but how do you manipulate that through a user interface?
Well, the user interface is the last thing we've added, and it's rough around the edges. Right now, if you're the organizer of the conference, you have a button which just starts recording. The recording is stored on the server, and then that's how far it goes. Then you have.
It also asks for a password, though, right? So that people don't go and amuse themselves on trying to start recordings.
So yeah, you need a password to start the recording, so that not anyone who can use jitsi.book.me, which is anyone, can use the resources. So after recording is done, you need to manually go and run a script which will run the post-processing. And the files are available on a web server.
So I'm actually showing a view into the folder that we looked at yesterday when we were doing a post-up. So it's actually, the YouTube stream is seeing you side by side with that folder kind of all zoomed up. And you'll note that there is a July 4th folder, which has the current time and your location, the server's location there. So, and if we navigate into that, we'll see.
I'm guessing you're sharing this on the Hangout, are you?
I am. A whole bunch of MP3 files and WebM files.
Yeah, the whole bunch of MP3 files are actually, they're mostly empty. It's an artifact of the process, and most of them aren't used. Generally, there's a couple of MP3 files for each person, but when you mute yourselves, when someone mutes and unmutes, it restarts in a new file so that we don't have to fill in with silence.
That was actually a pretty interesting thing to do, because something you don't, so one of the challenges of recording is the post-processing, because you never think about it when you're actually in a video call, but even when you're talking to a single person, there are multiple video streams being exchanged. There are multiple audio streams, and all of this needs to be flattened into a single video. So that was one of the challenges. And in order for the post-processing to happen, you have to have recorded enough metadata that says this stream started then and then stopped then and blah, blah, blah. Another one of the challenges is that Boris uncovered during his work on recording was, and I'm sorry, Boris, I hope you're fine with me talking about it, but please feel free to interrupt me. So it was that when you're in a real-time session, you have a lot less timing problems, okay? Because you're just playing whatever comes to the network, and you cannot overplay because well, you haven't received enough data. For example, when you're playing audio, you need to wait for the current samples to actually play out through your device, and only then you can pass additional samples. So imagine that you're getting in your jitter buffer 10 audio packets that have been delayed. No problem, they're just going to play through normally. Potentially you might even drop one or two because you know that there's a delay. You don't have that blockage at the device when you're recording. You can basically just record everything or drop everything. That creates a lot of synchronization problems. For example, in cases where any of us would mute ourselves currently, our audio traffic wouldn't be relayed because it's just silence. it would be pointless. But that also means that the audio recorder isn't getting it. So it needs to register the fact that nothing else is arriving, and potentially pass record silence or create a completely new recording. And making the choices between these possibilities has been one of the parts that were a little bit tricky to get right. We had to start them. We did them one way, then we went and did them another way. And yeah, Boris, do you want to add something there? Or?
No.
Well, that sounds like a really good time to call for last questions. It's 5:02, and we don't want to make it too much longer than an hour.
And we've got Carl in there somewhere as well, haven't we?
Where is Carl?
I have a question.
Oh, Andy, go ahead.
Yeah, I'd like to know how much of this is now configurable, Emil. What sort of like bells, whistles, and tweaks have we got in the configuration files?
Actually, the video recording is already configurable, and you can enable that in your own installation. Boris, would you want to describe how that happens?
Oh, for recording, it's very simple. We only have configuration which enables it, and then a property for the authentication token, and then a property for the output directory. That's all.
But where does that happen? You have to. It's not in the config.js.
No, that happens on the video bridge. So it would be on the server side.
Yeah, it's in the zip-communicator.properties file that you. Anyone who's running Video Bridge is probably already tweaked in order to disable the replay time detection because of a Chrome peculiarity. So it's in there. We should, you know what? That's actually a good question, Andy. We should just go and update the tutorial for the Jitsi Media installation to explain how people can enable recording on their own servers.
I think that would be good. I have heard rumors, although I haven't actually looked at this myself, and I haven't asked you. That you can configure the default video rates up higher. Is this true?
The resolutions, yes, you can.
Yes.
Yeah. By default, it goes to 360p, and you can do them in 720p if you want. Yes. That happens in the config.js. I thought it was in the example file that we have, but maybe not. So yeah, that's definitely just one line of code.
Yeah.
Of configuration.
I'm playing here a little bit with kind of a multi-angle aspect. You can see me twice. I have a tablet on my right side and the webcam on the PC in front of me. And sometimes I do see the image on the tablet. Other times I don't. But I was wondering if everybody is seeing both angles of me.
Yeah.
Yes.
Oh, okay. So we have basically a multicam meeting here, I guess.
And they're both in sync as well, which is pretty
Right.
impressive.
That's interesting.
I forgot to turn my other camera on, so I can't use it right now. So did we get Carl's question? Well,
Assuming that Carl does have a
I'm
question.
I do have a question while we're waiting for Carl, and that is the post-processing of the recording. What kind of processing is involved, and that is it accelerated in any way using any kind of hardware, and what kind of performance does it achieve?
Boris, do you want to take that one?
Yeah, we're using regular machines. We have an application that uses FFmpeg. It mixes audio, obviously, and then combines the videos together. About the performance, it really depends on the amount of the number of participants, obviously, and then on the number of speaker change events, so that if people change more frequently, the speaker changes more frequently, it will take longer. But basically, for a 4-person conference, the post-processing takes about 0.6 times the length of the recording. And this is on a virtual machine with 2 cores at 3 point something gigahertz. I don't know the exact specs, but it's actually on the machine which is running the bridge right now.
So you're saying at 0.6 then it's faster than real time?
Yes.
Excellent.
That's actually the result of a lot of optimizations, because we started at about 8 times the recording. The post-processing would take 8 times the recording. And then it took a lot of tweaking with FFmpeg and optimizing the sequence in which we post-process, and in order to bring it down to less than once the recording.
Let me mention again this idea of who's doing what, in that when you use Google, like the Hangouts, we have done Hangouts where the recording was available pretty quickly afterwards, but sometimes the processing takes twice as long as the record. It really depends. It seems to be exponential, by the way. So if you do, because I have done 3 and 4 hour. I think Dan York, for example, was doing 3-hour recordings when the maximum used to be 3 hours, and it would take more than 3 hours to process it. So
You're talking about compressing the video?
Well, I don't know what they're doing. Who knows? See, this is the problem when you're using somebody else's service, is that you don't have any idea what they're doing, and you also don't know. Well, you also don't know what their cue is either.
Because they're encoding into fashion that supports all the different playback formats.
Yeah, but you also don't know what it depends on the cue. Yeah, but it depends also on how occupied they are. So it depends on the time of day. It depends on the time of year. Who's doing what. I don't have any idea how that all works. The traffic, the load of their servers and their infrastructure at any given time is obviously a variable that none of us control. For all I know, they don't control it themselves. So that's just another little point I wanted to make. We're at an hour and 2 minutes about. Anybody have any questions or comments further?
Well, I had one other.
Sure.
The appearance of the thumbnails on the bottom, it looks like they come in the order that the speaker joins. But is there a way to change that order?
It would be very easily implementable, but it's not currently possible.
An interesting point, though, that I hadn't much thought of, which is that it's kind of, because it's not necessarily a super important thing, but at the same time, if it was, you might want to change it. I mean, these are things that...
Well, actually, certainly, as we get to a point right now where we have more participants than fit in one row.
Right.
If you're going to have a second row, the first row should move up so that the little guy's not hidden off screen.
The second row that you're getting is not, it's just the thing that happens. It's not deliberate in any way. So,
and also, one of the discussions that we had was determining whether, how many people you want to show up at all in the thumbnails, and that's something that we kind of have to. It's one of the things that we're doing, like at times like today, which is to do these tests, and that's why what I call it a burn-in. We're testing all this stuff and seeing, well, when you're actually doing it, what sense does any of this make, and what are the priorities, and what needs to be done. But this is great.
Yeah.
I was just going to say, so right now, one of the things that we're going to do that's going to be the most interesting would be to look at the recording and see if there's been any problems or how it's going to be put together and so on, and compare it to the recording on YouTube, which, of course, I'm going to stop in just a second and let that process, and it'd be interesting. I won't be able to do this, but it'd be interesting to see how long that takes to be posted. So that's about what I have to say.
Well, I think it's a remarkable technology that you've developed here, and I applaud you for having this operating, because it is a very complex area, and the fact that it actually works is very impressive.
Thanks very much.
More.
Very much appreciate that.
All right, so with that, I think we'll stop the broadcast. And, of course, the VUC private mature audiences only thing can go on as long as anybody wants to, but I am going to stop the broadcast. Thanks, everybody involved, and we will see you next week with 497. We're rapidly moving towards number 500, and that's going to be terrific. We'll see what happens then.
And we have a special guest there.
Yes, we do. But we're going to keep that undercover until 5.
So you're not going to tell us who the special guest is?
Of course, Emil.
No, not me.
No, I mean the name of the special guest.
It's going to be the CTO of the Federal Communications Commission in the United States.
Oh,
Henning Schutzring.
Henning. Sorry, Henning.
The father of SIP and father of RTP and father of SDP and other 3-letter combinations.
So that'll be a monumental 500. Until then, everybody who's watching on YouTube, if anybody is, we'll talk to you later. Bye.